Hi and welcome to this video about the bit service. In this video I'd like to show you the basic way to work with the bit service. So you might be wondering, what is the bit service anyway? So this is a service that is built into Windows. It's short for Background Intelligent Transfer Service, and it's a service implemented in a DLL called qmgr.dll, which is hosted in the standard SVC host, which hosts most services in Windows. And its basic role is to provide support for uploads and downloads. And so it takes care of all the management aspects of uploads and downloads in a very simple to use way, relatively speaking. You don't have to worry about connections, reconnections, retries, errors, things like that are all being taken care of by the service. So I want to show you how to work with this service. And it's asynchronous in nature, which makes things a bit more complicated, but definitely worth it because it provides flexibility. So let's see what that entails. So I'm going to go to my trusty Visual Studio here and create a new project as always. It's going to be a C++ console application project, just like I typically do in most demonstrations. I'm going to call it something like bits demo and just put it in my YouTube folder. Like so. Let's start with the usual stuff, which is adding the appropriate includes. And so the way to work with the bit service is using an API that is provided by the service. And as it happens, this API is COM based. It's based on a component object model. So if you're not super familiar with that, you can watch some of my other videos that talks about COM. But in any case, it won't be too difficult, I would say, at least not in the first part of the video, to use the actual functionality. So I have an include here for Windows and stdio to get printf support, but I also need the include for the bits service API. And so it's available using this file called bits.h, and that's of course all good and well. Now, because this is a COM library, you could actually use an actual type library, but in this case, we do have a header file provided by the Windows SDK, so just going to use it. This contains all the definitions of all the interfaces, the GUIDs, the methods, everything that we need. And lastly, since we're going to do some COM work, we should use some smart pointers to access the COM objects, so we get automatic management of add, ref, and release, all that reference counting stuff. So I'm going to use ATL here. We can use ATL by including ATL base.h or something a bit more specific than that, like ATL COM client. It doesn't really matter. If you are accustomed to another kind of smart pointer that you want to use, that's of course perfectly fine. So the first thing to do is to do a co-initialize, and co-initialize EX expects two parameters. The first one is reserved, the second one is the kind of apartment. So I'm going to start with apartment threaded, that is the single thread apartment. Actual discussion of apartments is beyond the scope of this video. Maybe we'll do something about that in a future video. Anyway, once we have that call in place, we can go ahead and start working with bits. Now, bits is fully documented, and the way you work with bits is to start with a root object you create with a normal corporate instance call, and then from that root object you get other objects as needed. And as it happens, the interface is called iBackground Copy Manager. That's the interface name. Let's call that MGR. So I'm going to create a smart pointer out of that, and then I'm going to call the create instance method on the smart pointer, which just calls corporate instance behind the scenes. And so in this case, we need the GUID of the background copy manager. So again, there's a convenient GUID we can access using the UID of operator. It's just a GUID behind the scenes. We can of course do an F12 here to get to that GUID explicitly. If we really wanted to, we can find the actual GUID. This is it. That's the one. It just has some nice compiler magic to allow us to use the UID of operator to get the GUID based on the names. Just nicer than using a different mechanism like the actual data structure behind the scenes. If that fails for whatever reason, so the H result is negative, then I'm going to call a helper function called arrow and provide the HR. This arrow is going to be a very simple one. Just going to get the H result and display the value in case we have some kind of error. Let's do that, error, and then let's display that in hex. And that's it. There's nothing else we can do here. So my error handling is going to be a very, very simple one. Just bail out in the first sign of error. So once we have that in place, the next thing to do is to create a job. So a job in the context of bits is really a work that needs to upload or download one or more files. So to do that, we're going to get to the Iberian Copy Manager interface, and there's a function here called create job. So we're going to create a job. We can give it some simple name like simple job. This is just a nice display name we can use to view this job in tools that may exist. It doesn't have any actual effect on the operation. Then we need to provide enumeration indicating what kind of operation is that, download or upload. We're going to do a download operation. And then we get two kind of results here. The first one is a GUID representing the job. That's some kind of ID that uniquely represents the job. And then also we get a pointer to the actual job object we can then interact with. So I'm going to first create a smart pointer here for our background copy a job. That's what we need here. We need a job. So here goes. Here's a job. And we also need to provide a GUID. Although we're not going to use this ID, we still have to capture it. And the result is an H result, as in most cases is what happens in the COM world. And so again, if it fails for whatever reason, just going to bail out. Once we have that job, the job currently has 0 files, so it's time to add files to the job. So the job has a function called add file, which we can use. Of course, there are other ways of adding files, but we're going to use this simple approach. And here we need to provide the remote URL and the local name. So the remote URL is going to be a link to some test file I found online. So here's a 500 megabyte test file, but of course we can choose anything. And then the local name is going to be some file on my system here. Let's call that myfile.bin or whatever. Some file that's going to be the final result if everything goes as planned. And again, technically it shouldn't really fail, but let's just make sure if it does fail for whatever reason, we'll just bail out. Once we do that, the job is created with a file, but it's created in a suspended state, which means that to actually get the networking operation going, we have to call a function which is called resume on the job. We're going to say, okay, we're done. We've added just one file. We could have added more, but in this case, I'm going to use just the one. And then resume will actually kick the operation into action. And again, I'm going to do a very simple check here that if anything is wrong, let's just bail out. So what happens next? The operation is asynchronous, which means that resume returns almost immediately, and now the operation is in play. And so we need to know when the operation completes. So the first way to do that is by using something called polling, which basically says, let's ask the job, is it done yet? So let's do that first, and then we'll try to find a more sophisticated, a more efficient mechanism. But for now, let's begin with this approach. So I'm going to create an infinite loop here, and I'm going to get the state of the job to see what's going on. Is it done or not? You can see there's an enumeration here called bg job state. Let's go ahead and create an instance of that called state. We're going to get the state here, and then we can check the state. If the state, as you can see, there are a bunch of states. Let me press F12 here. Here it goes. You can see there's a queued state, connecting, transferring, suspended, error, and so on. And so we want to check for two states, the error state, that's one, or that we're done, which means transfer, that's the state value here. So I'm going to grab both of these and check. If the state is either one of these, then we're done. Let's just break out of the loop, which means we either completed the transfer or there's some error, which means that the transfer failed and we can't really move forward. So if that is happening, then of course we're just going to bail out. If not, it probably means that the transfer is in progress. So what I'm going to do here is just do a little printf here for a little dot, just to indicate that something is happening, and do a little sleep, like for a half a second, and then continue with the loop until one of these two states happens. Once we're done, we have to check what has happened. How did the job fare? So if the state, the final state, is in fact transferred, this means that the operation succeeded, which means we can complete the actual operation. And completing just means we have to call the complete method. And the reason for that is that, as we'll see, the actual file that's being created first has some temporary name, and only when we call complete, the actual result is landing in the final file name, and the file name is renamed to the actual name that I provided. And then we can just write something like success or something like this. Otherwise, something went wrong, we have some kind of error. In fact, we can get more information by querying the job for an error object. So there's a getError function here, and with getError we get another COM object implements an interface called iBackgroundCopyError. So again, we're going to create a smart pointer for that, iBackgroundCopyError. Here goes, let's call that ERR, and just get it here. Once we have that, we can call some methods on this object, like maybe getErrorDescription, which seems like a good idea. And so we just want some textual description here. So the first parameter is the language, and I don't really have anything special to say here, so we can do something like user default, lang user default, providing some ID that indicates that whatever the user's default language is, I'd like the error in that language. And then the result is a pointer to a pointer of the actual text. So I need to provide a pointer here, and this pointer is being allocated by the function and returned to me. So I'm just going to verify that there is some kind of text here, and if there is, if the H result is a successful one, I want to display it. So let's say error, and just display whatever that error is, a Unicode string. And since this function actually allocated this string, we actually have to deallocate it. So it's not clear why I'm calling this function, but that's the right function to call. It's called callTaskMem3, and this uses something called the COM task memory allocator, something I might discuss in greater detail in a future video. But for now, it's just to make sure we don't leak memory. I don't like to leak memory if I can help it. And basically, we're done. At least for now, we should be done. So let's go ahead and test this out first. So one thing to note is that the bit service is actually very useful, not just because of its functionality, but also from a security perspective. When you initiate these kinds of operations, it's unclear which process was actually the initiator. And so what we'll see is that the process that hosts the bit service is the one that actually is doing all this stuff, all this networking stuff. But it's unclear which process was actually requesting that operation. So first, let me just run this to be I would say optimistic, just to press Ctrl F5 and run this. So here goes, and you can see here, this is my folder. You can see there is a temporary file name here. We can see that the file is being downloaded, at least we hope that it is, because we don't get any particular information here until it's shown as success. And you can see that indeed it's a 512 megabyte or 500 megabyte or so file, and the final file name is myfile.bin. That worked pretty well. So let's try it again. And just for fun, I'm going to launch a tool called TCP-View. So TCP-View is a sysinternals tool that can show us dynamically what is going on in terms of TCP and UDP operations on the machine. And so I'm going to perform some filtering here and filter for the bit service. Now the bit service is hosted in a SVC host here, as you can see. We can find it in a different way using Task Manager. So notice there's a services tab here. We can look at bits. Here goes. And you can see it's currently hosted in a process with ID 22704. We can right click and go to details. We get to the actual particular line in Task Manager's details tab. So that's this specific SVC host with the process ID 22704. And TCP-View, of course, mimics that and just reassures that this is in fact correct. So if I go ahead and run this again, let's go ahead and do that and look at what is going on here. Notice that new connections being created. Now you can see that the bytes have been received and sent as part of the work of the service. At the same time, of course, we can see that things continue to move. But as you can see, things, well, maybe I didn't really start as I was hoping. Let's do that again. So here goes. So now it is downloading. We can see that we get receiving packets just like before. Actually, we just don't see the received bytes, but they're right here. So you can see received bytes right here, same thing. We just ran it again. So packets versus bytes. So you can see we have two transfers here, like roughly 500 times 2 megabyte with some overhead related to network stuff, like TCP stuff. So obviously this is part of SVC host, and so it's unclear that my particular example here, bits demo, which is a different process, of course, was the initiator. In order to figure this out, to see who exactly is the client, we actually have to go to the kernel debugger and look at some things more internally, which we're not going to do in this demo. In this demo, I'm just going to focus on the API in user mode. By the way, if we do this with the debugger, let's go ahead and try this again, this time with the debugger. I'm going to do an F5 here and go and create the initial management object. Here goes. And you notice what I get back if I just hover here is actually a proxy to the object, because the actual object, of course, is in a different process. You can see it's part of bitsproxy.dll. That's my local stuff here. But the actual object is in a different process. And we know what that process is, in fact. Even though we might not see full information here while we're looking at the debugger, it's clear that it's not a local object, it is actually a proxy. There are other ways of seeing that, but this is out of scope for this video. Then we're going to create the job. Here's a job object. You can see it right here. Here's the job. This job object is also something that is provided by bits proxy here, and so on. So at this point, we have here this idea of looking at the information by polling. So I'm going to delete the file so we can make sure we're getting a new one every single time. And we've used this little dot print here, which is not very satisfying perhaps. So one other thing we can do, instead of just using a get state, we can say that if state is in the middle of actually transferring data. So let's go ahead, there's a state called transferring. Then we can call another function called getProgress. It can give us more details as to the actual progress of the operation. And so we get here a structure called bgjobProgress. So let's go ahead and define that. Here's our progress structure. And this structure has 4 members. You can see there's bytes total, bytes transferred, files total, and files transferred. Since I'm transferring just one file, obviously that's not going to be very useful for me. But let's go ahead and just get this progress and display some information about that instead of just having this dot being displayed. So I'm going to do \r to do a carriage return, to just go back to the left, and then display something like bytes. And I want to display the number of bytes that have been transferred compared to the total bytes there. And let's just use kilobytes, so because bytes is probably a bit too granular, too big a number. So let's go ahead and look at progress. So we have here the bytes transferred. I'm going to shift them by 10 bits to just convert them to kilobytes, and then do the same thing with bytes total, like so. And let's do a smaller sleep so we get better updates, perhaps. But we're just going to poll again. We're polling, asking for the progress. So here goes. You can see it starts, and indeed it moves forward. We see the progress, which is nice. TCP view should also see us here doing stuff, more bytes being received, and so on. So that's a bit nicer, I would say, because we see some progress, which is definitely an improvement. The next step, which is more tricky, is to instead of doing something like this, which is about really just polling. Polling is not super nice. We might want to do something more efficient to get information while the operation is in place and get notification when the operation is finally done. So the question is, how do we do that? And so as it happens, the job object here has a function called setNotify interface. So the notify interface is a way to provide callbacks. So in the COM world, callbacks are interface implementations. They're typically not just free functions or just C-style functions. So you can see there's an unknown pointer here, which is completely unclear what that thing actually should be. But of course, documentation says exactly what that is supposed to be. And so if we go to the documentation, here's my offline documentation. Let's look for something like set, let's go with the job object here. So let's find the interface for the job object. You can see there's a function here called set notify interface somewhere. Set notify interface, here goes. And it says that this thing actually should implement this interface, iBackground copy callback. It's not just some random interface. This is what is actually being looked at and queried by the bits infrastructure. We need to implement this interface as a COM object. So we have no choice, I guess. Let's go ahead and implement that. In order to do this, we need to create a class. Let's go ahead and create a little class to do that. I'm going to do everything right here in the same file for simplicity. Let's call that notify callback. I need to implement the interface, this one, iBackground and copy callback. And this is a COM interface, and I could have used, I can use technically some helpers from ATL, for instance, but I'm going to implement this interface here like completely manually. I'm going to go to Visual Studio to see if it can perhaps provide the implementation for that class. Just give me the definitions for this function, and it does. You can see we have 6 functions here. 3 of them are from IUnknown, which is something that every COM object must implement. And then in this case, there are 3 unique functions for this interface that provide information about the operation. You can see it transferred. That means the operation is done. So it's done successfully. Job error indicates that something went wrong, and we get even the error object already ready to go. And finally, we have job modification, which presumably is going to be called every time there's something that has changed, like a new state, or maybe more bytes have been transferred, and we get some kind of intermediate notification while the operation is in progress. So let's go ahead and implement this stuff. Add, ref, and release are the simplest. I'm going to just return some random numbers which are not 0, because I'm going to create this object on the stack or globally, so I don't really care about actual reference counting. That's just my choice in the way I'm going to use this object. In query interface, I have to do the right thing, so I have to make a check here. If the interface that is required, UUID of, is IUnknown, which I always have to support, or the interface that is requested is this one, the GUID for this interface, the callback interface, and of course I support that. And to do that, I need to provide the pointer to myself to do something like this. No pun intended. I'm just returning this. I'm not even bothering to call add ref. There's really no need because I don't really manage any reference count. Otherwise, I'm going to return in no interface, indicating I was asked for some interface which I don't really support. And then once we have job transferred, we know this is about really the case where everything is fine. And so we can do that in several ways. We can deal with that in several ways. One of them is just do the work here, like saying something like success, and be done with it. Or maybe you want to signal something and let some other code pick it up, but let's start with this little simple idea. If we have an error, then obviously something went wrong. And again, what we want to do is, in this case, display the error. So I can go ahead and take my code from here and just copy the basics there. All I need to do is to get the error. So I'm going to copy this thing here and just display the error based on that error object. So I'm going to use the error object here to call the description and then just display the description, and I'm done. Nothing else I can do here. And then we have job modification. This is where we want to perhaps get some information to display as progress, just like we did here. So I'm going to do that as well. So let's go ahead and do that. I'm going to grab these two things here. We're going to get the state, and if the state is an appropriate one, we're also going to grab the statistics, the progress itself. So here goes. Let's add that and make the appropriate fixes. So first thing, we need to get the state. Obviously, we don't need to check for that specifically. So it's called pjob here. Let's go with that. And if the state is transferring and we can get the progress correctly, let's just display the progress like so. And then we can return SOK. The return value here doesn't really matter because nobody really cares. But still, we're going to return SOK as a kind of a default value. So we have the job, we've used it, and we get the result. Okay, great. So how do you use all that stuff? Obviously, lots of these things are now irrelevant. Let me just, well, I'm going to just remove them. Let's just remove everything here. So we need to set up the notify interface. In fact, I want to do that before I call resume. So I'm going to create an instance of our notify callback object. I'm going to create it like so and just pass the address of that, which is implementing the inon interface and derives from inon. That's why this thing should work just fine. If this fails for whatever reason, it shouldn't, but if I messed up in my query interface implementation, for example, this might fail. I'm going to just bail out again. And now we have resume. So what should we do next? What should we do here? If we don't do anything, our process will shut down and we won't get anything. And in other more complex cases, this thing might be part of some other application, like maybe the application has a graphical user interface, something like that. And then that would probably have like a natural way to return to message pumping. But here we can start maybe with something very simple like sleep infinite, like so. Or maybe not just infinite, maybe we should do something a bit better. Let's go ahead and have an event object here. Let's create a global object. Let's have a handle here. Let's call that done. That's going to be a done event, which we'll create, of course. And when we get one of these two options, instead of just returning, we're going to just set the event, saying that essentially we're done. So that we're not going to wait forever. I don't want to sleep forever. I just want to sleep as long as we have the operation in progress. So the idea here is that before we actually make the call here, I'm going to first create the event, the actual event. So we have hdone here. I'm going to create the event. This is just a normal Windows event object that allows us to signal something like a flag. So I'm going to make it auto reset, which means just one thread can wake up when that thing is signaled, which is fine. This case doesn't really matter. And then we're going to start the event in a non-signal state and doesn't really have doesn't need to have a name. And so now once we do the operation of set notification callback interface and resume, the only thing that we need to do here is basically to wait for the object to become signaled, which could be signaled in one of two reasons, because of one of two things: either the operation completed successfully or we have some error on our hands. By the way, we didn't actually test the error condition, so that would be also something you might want to try right now. So here's our event. We can wait infinite, or we can even wait something finite, let's say something like 60 seconds, because if we don't get that in 60 seconds, we can conclude that something really bad is going on, and maybe the network is stuck or something more severe is happening, because we expect this to work until, let's say, 60 seconds. So if that doesn't work out, I can write something like timeout. Otherwise, we have some result, which means either a definite success or a definite failure. Okay, so we have this wait here. Now we can try it out. Let's see if this works. So I'm going to press F5 and see what's going to happen. Here goes F5, and we stop here at the breakpoint. I'm going to let it continue running. So here's what's going on here. It seems like something is stuck. Something seems to be stuck. And I never get to the various notifications here. So here's a successful transfer, some kind of error transfer. Here's a breakpoint in the progress notification. I'm placing breakpoints in all of these, and it just doesn't seem to happen. Nothing seems to work as expected. In terms of transfers, it's unclear whether we actually had something happening here or not, because I didn't start the process from start, the TCP view application. So something here is obviously off. Something here is wrong. Something doesn't really work as expected. Let's try it again, actually. So here goes, and we're stuck. Let's see what is happening while we get stuck. Let's just break into the debugger forcefully by pressing this pause button here. See where we are. And so you can see that if we look at the threads here, we might find several threads. The main thread is stuck in wait for single object, which makes sense, because the thread is waiting for the event to be done, and nothing seems to be moving here from that particular location. We have other threads here, but they belong to the thread pool, so they're not perhaps that interesting, even though we can definitely switch to them and see what is going on. So it seems to be completely stuck, but of course there's a good reason, because maybe the operation is not yet done. But maybe the reason is different. And this is definitely not something that is clear. It's not really clear why we get the result that we do. And here's one way to solve that. One way is to change the apartment here to multi-threaded, like so. Once I do that, magically it will start to work. Let's see. So I'm going to run this, see if we get somewhere. Well, apparently not. Or maybe yes, job transferred. And so I get the information that everything is done and it's been successful apparently. Now the event is going to be set and we're going to be done with the application. So I press F5, we're now done. We get success. On the other hand, if I do something which is bad, like for example, provide a bad URL, like adding something like this, let's see what happens now. So if I run this again, now I expect things to fail at some point. Here goes. We get to the job error call here. And notice, by the way, that the thread on which this happened is some thread which is not the main thread, some other thread here that is part of the process, which perhaps is not obvious why this is the case. In fact, this is part of the reason this works, because the main thread is still waiting on that event object. And once we're done, of course, we'll get to this location. So now if I continue, we'll get back here because the event has been signaled here by the error here. And of course, we see the actual error. The server did not return the file size, blah, blah. So there's some error here. Obviously, I provided the bad address, so not a big surprise there. So there are a couple of questions here. So first, how this magically solve the problem? Secondly, why didn't we get any job modifications here? I mean, why didn't we get called every time something moved forward in the job? So this last question perhaps could be answered by information about the copy callback. And before we actually call this copy callback thing, the set notify interface, I think there's a bunch of flags we can specify, set notify flags, indicating which operations we actually care about, which operations we'd like to get information about. You can see there's a flag for modification. And since we didn't call this function, then unfortunately it's not part of the default values. And that's why we didn't get the particular notification. So if we change this, we can call this function with this particular flag and maybe some other flags, of course, like error and transferred, which of course is something we want to receive as well. We'll be able to get those notifications. Okay, so let's try it. Since we're here already, let's go ahead and try that. So before we call the set notify interface, we're going to call set notify flag and provide these flags, like we have transferred, we have job modification, and we want to provide the error in case there's an error. So if we do that, then hopefully we'll also land in the modification callback. So let's see. And you can see we get into modification very quickly here. You can see we have some kind of state. If we call that, of course, the state in this case is actually error. which is again not surprising because I haven't fixed the problem with the URL. So let's go back to the URL here and fix it back, and press Ctrl F5 now to run this kind of normally. So now we can see we do get these notifications because of those flags. We'll get them in a similar way as before, but now we're not doing any kind of polling. We just get notifications when there's something to notify, when the bit service knows that there's something that it wants to tell me, instead of me just polling in some interval without actually knowing when there's new information to be available. So that's that. Now still there's the first conundrum. Why does this change actually allows all these things to start working? And this is unclear, and this is something I can't go into in this video, but this actually has to do with the information about apartments, which I briefly kind of mentioned at the beginning. However, if we go back to apartment threaded, can we fix that in some way? Is it possible in some way to fix this thing so that we don't get stuck in this case? Well, actually, there is a way to fix this. There are actually maybe two ways of doing that. One of them is basically what we need to do here is to pump messages, because the way COM works when you have a single thread apartment is by sending messages to the thread that created the initial COM object. And so we need to pump messages just like we would do in a user interface application. In this case, it's about messages that are provided by COM. So that's just custom messages and that are targeting some hidden window behind the scenes. So just this is kind of in a nutshell the actual reason. So if I do something like this, maybe just a simple message pumping, we'll get that information as well. So if I go ahead and run this just for fun, see what we get. So here goes. We can see that it works as before, but there's a little snag here because we have an infinite kind of pumping there, which means that it's never going to end. The process is going to be stuck here in this get message, dispatch message infinite loop, because get message returns true until you send or a message appears, which is a WM quit message. And so that's going to mean that we're going to be stuck here. There are two ways to get around that. One way, which is the simplest one, instead of just setting the event, which is kind of useless right now, you just use something like post quit message, which just places a WM quit message into the message queue, and that will do the trick. Same goes in the case of error, of course, because in the case of error, we also want to do that. So technically in the case of a job transferred properly, this is going to actually happen. And then this wait, of course, is completely useless at this point, because we know that that's good enough. The operation is done. And that would be one way to get out of this little mess. So let's just verify that it actually works as expected. So expect now the application to shut down properly when the operation completes, or if it would get into an error state. So we have a couple more seconds for that. Here goes. And we're done, and we're out of the loop here. So in fact, the event object here is not really needed. There's another way of doing that. Instead of using getMessage, is to call another function called messageWait for multiple objects, which is a way to wait on a bunch of objects, in this case just the one, and also wait on Windows messages, that is UI messages, which basically would be something similar to what we've seen here. In this case, we would dispatch the message. This is slightly more complex, but more flexible. We don't actually have to wait for WM quit message necessarily. We just want to pump message until this event is signaled. So I'm not going to show the full code here, and that's left something for you to try out yourself if you want to give it a shot. So there you have it. This is the basic way you work with the bit service. It's very flexible, and all the network operations are going to be seen as coming from that process, which makes it unclear which process was actually the initiator. And maybe in a future video, we'll take a look at how to figure out which process is actually the one that contacts the bit service.